Hey guys, and welcome to our next set of notes, 11.3, and this is forces. So we're going to talk today, what are forces and how do they affect motion? Sorry for my little cheesy pun there, because you guys know force and Star Wars. Alright, but the forces we're going to be talking about here, obviously determine if objects move or not, also determine motion. So we're going to look at that today and how it works. Okay, so how is a force defined? So either a push or a pull on the object. All right, so and what they can cause obviously is movement of the object. Again, if the force is strong enough to usually overcome gravity, usually is the main thing that's affecting or fighting you. They can also stop movement. Okay, so an example with soccer, all right? So obviously you can kick the ball forward, but you can also be the goalkeeper who pushes the ball outward, all right, the opposite direction. Okay, you can also change its speed, so obviously the more force you apply, the faster the object's going to go, the less force, the slower the object will go. We can also change its direction, all right? So again, so we can actually sometimes do what's called bending the ball, all right? They always say bend it like Beckham, all right, because he can do that amazing curvature on the ball, all right? And it's the way you strike the ball and put what type of spin you put on it. So, all right, so a soccer player kicks a ball, changes the ball's direction and speed. Okay, so Isaac Newton, all right, so obviously older scientists, you can recognize the picture. They used to wear those powdered wigs. But anyway, Isaac Newton is pretty much the father of this type of physics, and he actually helped also make calculus, which is one of the maths that actually explains all this. All right, so they name the unit of force after him. They call it newtons. And forces sometimes can combine or oppose each other. So obviously, pushes and pulls, they can act in different directions, and sometimes they're going to add up, sometimes they're going to subtract from each other. All right, so net force is the combination of all the forces acting on the object. And a good example of that is a tug of war. So obviously, two groups tugging against each other, you can picture that in your mind, and obviously, whoever has more force pulling in one direction is going to win. All right, so how do we calculate net force? Okay, what we do is we basically look at all the directions that the objects are acting on each other. So if the forces act in the same direction, like the first example here, they're 5 newtons in the same directions, they will add up. So 5 newtons plus 5 newtons gives you 10 newtons. So that's like 2 people pushing on a boulder, all right? Obviously, 2 people is better than 1, obviously applying more force. Okay, if forces are acting in the opposite direction, they will be subtracted, right? I always think of 2 NFL linemen, right, smashing into each other. Okay, so obviously if they're exactly equal, no one will move. Okay, obviously if this guy's stronger on this side, the other guy's going to basically get pushed back. All right, so forces opt in opposite direction, they are subtracted, or you can add a negative number, right? So in this case they did 5 and negative 5, or you do 5 minus 5, which will give you 0. So they cancel out in that case. Here's another example, 5 plus negative 10, or 10 minus 5, will give you negative 5. So they're doing, to the left is a negative direction, and then positive direction is to the right. So obviously the resultant, which is the adding of these or subtracting, determines whether the object moves or not. So a net force greater than 0 causes motion. Okay, so if there's 0 exactly, that means the objects are not moving. And these are what we call vectors. So we use vectors to describe the movement of the object. And obviously we can do this in 3 dimensions, but we're not going to do that at this level. That's more of a high school or college thing that they're going to be doing in the future with you guys. All right, so what are the 2 different types of forces? So obviously we have pushing forces, okay, which can include the following things. So it can be as simple as hitting a ball, closing a door, hammering a nail. All right, so they're all pushing away from your body. Okay, so again, baseball, when you hit the ball, you're pushing the ball away from you, and then it goes in the opposite direction. Pulling, we're doing the exact opposite. So pulling forces, we're pulling the object towards us. So it could be as simple as tug of war, opening a door if we're pulling the door open, lifting a box because you're fighting gravity, climbing a rope, you're pulling your body up as you climb, or an object falling because gravity is pulling it down to the ground. Okay, so obviously there are different types of forces. So the first one I want to talk to you guys about is friction. So friction is something that opposes forward motion. So force exerted on two objects, they rub against each other, right? And you feel it when you rub your hands together, right? There is resistance as you rub. So that's what we call friction. Obviously heat's the result of that. Okay, and there's two different types of skiing that is shown here. The first one doesn't work as well. So this is skiing on sand. The problem with it is sand is very gritty, as you know. Okay, so the friction is going to be greater with sand than it is with snow. Snow we think is slippery. So what can happen in this situation? Friction strength depends on the type of surface. Okay, so obviously the more gritty it is, the more things in contact with the material will actually resist motion. So doing it on sand, you'll end up typically fighting the sand, and you'll actually fall backwards a little bit. Whereas skiing on snow, there actually is a little bit of rubbing. There has to be, because otherwise you would definitely fall. And you're supposed to turn in like, C or S turn to keep control. The reason why you want some friction with the snow, and you actually partially melt it as you go through it, and that's what also helps you to grip the snow better. And with skiing in sand, you'll actually grip the sand too much. All right, friction opposes motion. That's also called drag force. So you need some drag force in this case, otherwise you'll go totally out of control. But if you have too much, then you can fall forward also, which you do with sand skiing very easily. So friction produces heat, so that's one of the resultants. And that's something that can be good or bad in some cases, all right? So with machinery, friction is actually very bad. It can wear out parts, all right, with the heat that's produced. Okay, next type of force is gravity. So force that pulls objects towards one another. So we always think of the famous one is Newton has the apple hitting his head, right? And that's what made him think of gravity, but supposedly that's folklore. It's not true, but either way, gravity is pulling objects to the center of the earth, right? So it causes objects to fall to the earth's surface. And the factors affecting gravity are mass. Okay, so the more massive an object is, obviously there's going to be more gravitational pull on it. And also the distance between the object. So the further it is away, the less gravitational pull. All right, and that's especially a big factor in space, all right, which we'll talk about in the future. All right, the objects that are further and smaller will have less gravitational pull than the ones that are closer and larger. Okay, also parachutes work on friction. Okay, so when a parachute opens up, you want a drag force, basically. So we have obviously gravity pulling this guy downward, and what happens, the air gets stuck under this parachute and slowly comes out around it, and that's actually how the parachute slows down your ascent down to the ground. So obviously if this doesn't open, you're in trouble, all right, because there's no drag force then. So you want that parachute to open up to drag you and slow down the fall. Okay, next force is magnetism. All right, so obviously this is invisible to your eye. It's not something you see. But the force of attraction of some materials to a magnet. So remember, iron, nickel, cobalt are the three metals that are typically attracted to a magnet. Magnets have both a north and south pole. Okay, and the north pole attracts the south pole of the magnet, and the two like poles will repel. Okay, so this is something we can use in different applications. Kind of neat. So obviously with a fridge, you want the attraction to happen. Sometimes we want repulsion or repelling. So if you ever seen like things that are kind of like floating, they look like they're floating. Sometimes it could be two magnets that are actually opposite poles repelling each other, which is kind of neat. So a little trick that we do. Okay, sometimes we also want to create a temporary magnet. Okay, so this is a wire connected to a battery wrapped around a nail. Reason why we would want to do this, you can turn the magnet on and off, which is really neat. Okay, so it creates a temporary magnet called an electromagnet. Okay, and stronger the battery, the stronger the magnet, and also the more coils of wire, the stronger the magnet. Okay, and this is actually used in basically school buildings. All right, so if you look actually on your stairwells, usually the doors actually are on magnetic catches. All right, there's a little thing that goes to the magnetic catch, and whenever we have a fire alarm that goes off, you'll actually see the doors close. All right, the reason why they do that is to keep the spread of fire between floors. They don't want the oxygen flowing between floors, causing the fire to spread more. So the closing of the doors, the electromagnet turns off, and then basically allows the doors to close. So neat little application. So these are used in different places, sometimes magnetic locks, things like that. But you can turn it on and off by turning off the power of your power source. All right, lastly, I want to talk about mass and weight. So mass, remember, is the amount of matter in the object. That does not change, right? That's constant, the particles that make up the object. Weight, on the other hand, is gravitational force exerted on the object. So in other words, when you're on the moon is 1/5 the size of Earth. So therefore, the gravity of the moon is 1/5 of Earth. So when you actually walk on the moon's surface, instead of just walking normally like we do, we get held down hard on the Earth's surface. You actually end up doing like almost like a floating a little bit. You do get pulled to the surface, but you actually take like bunny hops, as the astronauts described it to us. All right, so you do actually go off the surface a little bit. If something were to hit the astronauts with enough force, they can actually get thrown off the surface of the moon very easily, because it's 1/5 of the Earth's gravity. All right, so moon has less mass, less gravitational force. Objects weigh less on the moon. And there is something called a vomit comet, which we simulate this. It's basically a plane that goes up on a 45-degree angle, and then they ascend back down at 45 degrees. And when they do that, when you're on that free fall part, you end up floating. Okay, and the reason why, you're creating not zero gravity. I know a lot of people say zero gravity. You're creating a lesser gravitational pull, where you feel almost weightless and end up floating like you would in space. Okay, so space, you end up doing that naturally because there's less gravitational pull on you. There are things pulling on you still, though. So there's no 100% zero gravity, but in space, you feel that weightlessness that the astronauts experience, which is very interesting because you have to do things differently in space. All right, so that's it for this set of notes. Thank you guys for tuning in. I'll see you next time.